This is the second video for section 2.4, part 2, applications with linear inequalities. Set up and solve the following word problems involving inequalities. Dawn won a mini grant of $4,000 to buy a tablet computers for her classroom. The tablets she would like to buy cost $254.12 each, including tax and delivery. What's the maximum number of tablets Dawn can buy? Well, the total cost for the tablets would be their price times how many we can buy. Well, that's the variable in this case, so I'm going to say x, and that has to be less than or equal to 4,000. Now, normally we would just say equal to 4,000, but here we aren't sure if we have enough money to buy $4,000 worth. So that's why we put less than or equal to, because it's okay if we spend a little less. So now to solve for x, we divide by the $154.12 on both sides. And we get x is less than or equal to 15.74 and so on. So then to answer the original question, the maximum number of tablets Dawn can buy is 15 tablets. So notice, because of the inequality notation, that's why I know I don't round it up. Because normally 15.74 we would round up to 16. But because of the inequality, I know my answer must be less than or equal to the 15.74. So the whole number that's less than or equal to 15.74 is 15. Part B. Sergio and Lizeth have a very tight vacation budget. They plan to rent a car from a company that charges $75 a week plus 0.25 a mile. How many miles can they travel during the week and still keep within their $200 budget? So just like before, we're going to come up with an expression for the total cost, which is the 75 plus the 0.25x, and that has to be less than or equal to the 200. So I'm going to subtract 75 from both sides, get 0.25x equals 125. And then I could divide by 0.25, but that'd be the same thing as just multiplying both sides by 4. So then we get x equals, or is less than or equal to 500. So 500 miles is the answer. Part C. Felicity has a calligraphy business. She charges $2.50 per wedding invitation. Her monthly expenses are $650. How many invitations must she write to earn a profit of at least $2,800 a month? Recall that profit is the money that remains when costs have been subtracted from revenue. So there are multiple ways to do this problem, but what I'm going to do is her revenue, or how much money she makes, is 250x. And I want to earn a profit of at least $2,800. Well, that means I have to make $650 first to cover my expenses and then have an additional $2,800, and that would be my profit. So then this is our inequality. So we get 250x is greater than or equal to 3450. Divide by 2.50. Divide by 2.50. We get x is greater than or equal to 1380. So she has to make 1,380 wedding invitations. Part 3. Applications with compound linear inequalities. Due to the drought in California, many communities have tiered water rates. There are different rates for conservation usage, normal usage, and excessive usage. The usage is measured in the number of 100 cubic feet the property owner uses. During the summer, a property owner will pay $24.72 plus 1.54 per HCF for normal usage. The bill for normal usage will be between or equal to 57.06 and 171.02. How many HCF can the owner use if he wants his usage to stay in the normal range? Well, here we're going to have 24.72 plus 1.54 X, where X represents our HCF usage. And I want this to be between or equal to 57.06, 171.02. So now we can solve this double inequality for X. So I'm going to subtract 2472 from all three sides. 234 less than or equal to 1.45. Sorry, 1.54x is less than or equal to 146.30. And then divide by 1.54 on all three sides. And we get 21 less than or equal to x less than or equal 95. So they can use between 21 HCF and 95 HCF to stay within the normal range. Part 4, Applications of Absolute Value Equations, Inequalities. Absolute value inequalities are often used in the manufacturing process where an item must be made with near perfect specifications. Usually there is a certain tolerance of the difference from the specifications that is allowed, and if the difference from the specification exceeds the tolerance, the item is rejected. Mathematically, this is modeled by the absolute value of actual minus ideal is less than or equal to the tolerance. The ideal diameter of a rod needed for a machine is 60 millimeters. The actual diameter can vary from the ideal diameter by 0.075 millimeters. What range of diameters will be acceptable to the customer without causing the rod to be rejected? So the inequality would be actual, which we don't know, minus ideal, which is 60, and the tolerance is 0.075. And remember, since this is an absolute value with a less than, it's going to split up into an and compound inequality. So we're going to get x minus 60 less than or equal to 0.075 and x minus 60 is greater than or equal to 0.075. Add 60 to both sides. We get x is less than or equal to 60.075. Add 60 to both sides. We get x is greater than or equal to. Oh, sorry. I forgot to. So this is a very common mistake. I'm kind of glad I made it. Don't forget that when you switch the inequality symbol, you also have to have a negative on that side. So we get 59.925. So that means the range of diameters is 59.925 millimeters to 60.075 millimeters. And that is the end of section 2.4 notes.